Well, we have question 5.3. Question 5.3 says if sine A equal to P and cos A equal to Q, 5.3.1, we're doing 5.3.1 now. That says write 10A in terms of P and Q. So now 5.3.1, so we need to write 10A in terms of P and Q. In terms of P and Q. All right. It is given that sine A is equal to P, okay? But we do know, it is given that sine A equal to P and cos A equal to Q. Now, by definition, we do know that tan of the angle theta is equivalent to, say, sine of theta over cos theta. Okay? Therefore, we can answer this question by saying, therefore, tan A will be sine A over cos A. Okay? And now this means that tan A will be sine, which is Q. I mean, sine is P. And then cos is Q. So this will be equal to P over Q. Now we're going to do 5.3.2. The question says, simplify P to the power 4 minus Q to the power 4 to a single trigonometric ratio. All right, I'm going to write here 5.3.2. So we need to simplify P to the 4 minus P to the minus Q to the 4 to a single trigonometric ratio. Okay, we do know the value of P and Q. Okay, first of all, let's simplify. It's better for us to simplify P and Q as they are. I think so, because P to the power 4 minus, I'll write the formula first. There's a property that we call the difference between two squares. So I can write P to the power 4 like P squared to the power of 2 minus, okay, I can write it like, okay, I can write it like P squared to the power of 4 minus Q squared to the power of 2, okay, P squared to the power of 2 minus Q squared to the power of 2, because the property, the law of exponents says that a to the power of m, all to the power of n is equivalent to a to the power of m times n. So all over here, if we times 2 and 2, we get the power of 4 there. Okay? Same also, we can times this and then get the power of 4 over there. Now, why am I doing this? Because there's another property called the difference between two squares. It says if we have like a squared minus b squared, this is same to say a minus b times a plus b. Okay, so we can cross multiply, we can apply the difference between the squares here in this line. Now we can say this is same to say p squared minus q squared. Okay, and then p squared plus q squared. Why am I saying that? Because you see, we have like this is to the power of 2, and that also to the power of 2. Okay, p squared to the power of 2, q squared to the power of 2. Then we can apply, we have two difference between two squares, a squared minus b squared. Consider p squared as a and then q squared as b. Now we have like a difference between two squares here to apply. So now this can be reduced to this, expanded to this. Now we can sub in the values of p and q. So this will be p is a sine squared. So this is then sine, p is sine a. So this will become sine squared a minus q is cos a. So this will become cos squared a. Okay, times sine squared a plus cos squared a. Okay, can move this over. So what we have here what we have here is, okay, we do know this property in this trig identity, sine squared of the angle theta plus cos squared of the angle theta, this is equal to 1. So we can substitute, here we have it, this becomes sine squared A minus cos squared A. This is equal to, no, times by 1, okay? 1 is the same as sine squared A plus cos squared A. And then we do know also that another property that says, okay, maybe I should just write the properties here. Use the identities, okay? The double angle identity, we do know that cos of yes, cos of 2A equal to cos squared A minus sine squared A. So I'm going to use these two formulas to solve out this, okay? So this will become then, now the thing is what here I have sine squared minus cos squared. So this can be written like this. I can put a -1 in front of outside the brackets, okay? And then interchange the content. So this becomes like cos squared A minus sine squared A. Check this out. Just checking. Okay, if you times the -1 over in the brackets here, cos squared A minus sine squared A, you will retrieve sine squared A minus cos squared A. So if you times -1 there, this will make negative cos squared A, positive sine squared A. So you can write the positive in front, that makes sine squared A minus cos squared A. Okay, so it's correct if I place in the -1 in front of this bracket and then swap the difference, okay? We do have cos squared A minus sine squared A times 1, because sine squared A plus cos squared A is just equal to, this is just equal to 1. Now, then cos squared A minus sine squared A is just cos of 2A. So we have like, now we have like -1 times cos of 2A, cos of 2A times 1, and this is equal to cos 2A. That's what we had to simplify. Thank you.